Hello, everyone, and welcome to the Electric Education Center, session 24, final wiring. This is part 2. This session is a continuation of the final wiring, and last session was session number 23, and I spoke about devicing out and installing receptacles and connecting the electric range and the electric dryer and the garbage disposal before we ran out of time. I discussed some do's and don'ts of the installations and things to watch out for to keep the homeowner's installation safe. So in this session 24, I will continue on with other equipment in the single family dwelling unit. Many opportunities for error arise when final connections are made, and the HVAC system is no exception. Wrong raceways and raceway connectors, wrong grounding connections, wrong torque applied to the terminal connections. The HVAC connections are generally made correctly using the correct material methods, but if you're working with an HVAC installer for the first time, you better double check all their work until you're real comfortable with it. When equipment burns up, or someone gets hurt, or shocked, or a fire starts for any reason, you're all going to the dance. You're all going to court. You better be prepared to explain your work practices and wiring methods and be able to show photos of the same, photos of what you did and photos of what you did not do. In this day and age, there's no excuse for not taking pictures. Past the HVAC, Rich, how about the wall oven connection? How do I provide a disconnect for a wall oven? Well, the manufacturer just shows the wall oven being direct wired, and there is no access once it is installed. I guess there are wall ovens that have plugs and receptacles. I understand that, but generally they don't. But that's okay. You can go ahead with your direct wire, but don't forget to provide a breaker lock device that attaches to the breaker and stays there permanently, so that no matter who goes into the dwelling unit to work on the wall oven, they can simply install their own little lock and lock out the circuit breaker to keep themselves from getting shocked. The breaker lock method must be used for any and all direct wired appliances, period. I have two sample breaker locks here. One is square D, and you'll see that when you turn it off, you can put your lock through and keep that breaker off while you're working on the appliance. This here is another style. This is an old Challenger, GE, Murray, that type of breaker, Siemens. All right, so they have this snap-on hasp, and this stays on the breaker all the time. And when the circuit breaker panel cover is put back on, the code considers that to be a permanent hasp. You don't take this with you. Okay, that hasp just stays on there all the time. So no matter which one of us, like I said, no matter which one of us goes in, we can all put our lock on there while we're working on the appliance and be confident that we're going to be safe and nobody's going to turn the power on while we're working on the unit. Moving on to the electric water heater. Rich, why do I see a 30 amp 2-pole 1-arm disconnect switch for the electric water heater and sometimes I don't? Well, the reason is that if the water heater is within sight of the circuit breaker panel, the circuit breaker can serve as the disconnect. So if you read the definition of in sight from in NEC Article 100 definitions, the water heater would have to be visible from the circuit breaker panel and no more than 50 feet away. Problems arise when a water heater was within sight when the house was originally built, but due to finishing off of basement walls, now that is no longer the case. You can't see it from the circuit breaker panel and vice versa. Watch for this non-compliant issue when you visit older homes for your customers. And if they have finished off a basement and put up walls and it's not in sight anymore, then you will have to install a disconnect switch at the water heater. Now, it always pays to know the reasoning behind these NEC rules that I keep mentioning to you. The reason for within sight is, as in most every rule in the code book, it's there because there's been a body count or injuries that drive the need for this rule. So if the water heater is within sight of the circuit breaker panel, the installer can see if someone is walking up to the panel and playing with any breakers. Put up a wall to finish off a portion of the basement, and guess what? It's not in sight anymore. This is a dangerous situation for the plumber who is trying to replace a water heater. All right. He has to be able to turn off the power at the unit or at the circuit breaker panel if it's within sight. I recently installed a tankless water heater at at my lake cabin, and new technology and design makes it possible to get away from the waste of a big old tank of water sitting in the basement and being kept hot 365 days a year, whether hot water is being called for or not. The water heater in my cabin called for two 50 amp, 240 volt branch circuits. And the next size up units call for three 50 amp, 240 volt branch circuits. So you have to make sure that the right size electric service is installed in the first place. Read the manufacturer's recommendation for sizing the tankless water heater and embrace this new technology. The tankless water heater very easily pays for itself many times over by reducing the amount of electricity used annually. The tankless water heater works beautifully at my cabin, and you never run out of hot water no matter how many showers are taken in the day if it's sized correctly. Let's move into the bedroom. One bedroom trick is this. In a standard bedroom, you generally have between 4 and 6 receptacles, and one of them is switched for a floor lamp or a lamp on a nightstand. There may or may not be a ceiling light outlet also. So, some electricians will just switch the receptacle that is closest to the wall switch. Some will switch the receptacle located furthest from the wall switch. And some electricians will switch the receptacle that makes the most sense to be the one the homeowner would most likely use to plug in a lamp. But in any case, you can count on a call from the real estate agent or the homeowner saying that there is a receptacle that doesn't work, or they cannot find the receptacle that is supposed to be switched. Reason for this is because it's not allowable to switch the whole receptacle, meaning for a duplex receptacle, you can only switch one half of it because there always has to be a receptacle available for use. And what is required by the spacing rules of 210.52A1 is that no point on the wall can be more than 6 feet from a receptacle location. So there has to be one there that is energized all the time. And this leads to the 6 foot, 12 foot spacing rule. Like if you start at a doorway, the furthest you can go is 6 feet before you hit the first receptacle, and then you go 12 feet, 12 feet, 12 feet after that. And so you can only switch half of that receptacle. So which half do I switch? What half did I switch when I was doing electric work? I don't think people give this much thought, but I did. I always switched the bottom half of the receptacle because the lamp cord was going to stay plugged in all the time. And this way the top half was always available and easily accessible to plug in other items. But anyway, back to the location trick. What you do is simply turn the one switched receptacle upside down, or just opposite the rest of the duplex receptacles for identification. So if they're all ground pin up for all the receptacles, the one you want to switch would turn it ground pin down. And then that way there, you can handle that problem from the real estate agent over the phone. Let's talk about the outdoor receptacles now. Several things to watch for here, as the outdoor receptacles generally require an in-use or a bubble cover per NEC 406.9A and 406.9B. These outdoor receptacles are going to fall generally into two groups: wet locations and damp locations. A wet location is one that gets rained on and one that requires an in-use cover. A damp location is one that is outdoors but does not get rained on. These would be receptacles that are located maybe in a soffit or under porch roofs or on a closed-in deck, for example. For a damp location under a soffit, the old-style flip cap, the old-style garage door flip cap type can be used. The newer covers are the ones that are I have two types of covers here. Whatever cover you use has to be marked as extra duty. It says extra duty right here. It's hard to see. Okay, but this here type, you would have whether or not the cord is plugged in, you would be able to close the cover on this type. Now that's kind of bulky and it doesn't really look very pretty, but from the same manufacturer, okay, they have a lower profile style that you could use, and they come with different fittings in there, so you could use this for a duplex receptacle, a Decora type or GFCI type receptacle, or even a light switch. Okay, so this is a lower profile compared to the bubble cover. Okay, so you can see these things are kind of bulky and not very attractive, but there are, and believe me, there are many of these low profile designer covers available, different colors and all that. Get online and search around to find the one you need. With these outdoor receptacles, the questionable areas are the ones that are installed below an overhang or below an eave. In this situation here, just simply go by the 45-degree rule. If rain is coming in at a 45-degree angle, will it hit the receptacle location? If it does, then that is considered a wet location, and then the bubble cover or the in-use cover is required. Also, the outdoor receptacles you install must be tamper resistant, weather resistant, and GFCI protected. Now, the GFCI protection can be provided by a GFCI receptacle or a GFCI circuit breaker, depending on your situation. The outdoor receptacles are allowed, you should have took care of this at the rough-in stage, but the outdoor receptacles are allowed to be connected to the bedroom circuit, the living room circuit, or even the garage circuit. But it cannot come off of the kitchen appliance circuit. It cannot come off of a bathroom circuit. And it cannot come off of a laundry circuit. Also, one receptacle is required in the back of the house and one in the front of the house. The NEC does not say on the building. So these two receptacles can go anywhere in the front yard, like a lamp post, or on the backyard on a shed. Okay, they do not have to be on the house. They can be on the house, but they don't have to be. All right, let's move into the basement, talk about the basement receptacles. If a basement is going to be finished off, this would generally be wired at the rough-in stage. But if the receptacles in an unfinished basement are going to be installed on the concrete or the block walls, there are some restrictions. Back in the day, an electrician would install furring strips or 2x3s, for example, and then try to hammer in staples and smash the wood to bits. But the NEC these days, in section 334.15c, requires that a conduit sleeve be installed to protect the NM cable as it comes down the wall. This conduit sleeve is going to generally be 1/2 inch or 3/4 inch EMT strapped to the surface. And as it says in the code book, a bushing must be installed at the top of this sleeve. Then to finish the install, the NM cable, the Romex, needs to be stapled within 12 inches of where it enters that sleeve in the first place. Read section 334.15, and while you're at it, read that whole 334 article. So whether it's a finished basement or an unfinished basement, the receptacles must be provided with both AFCI and GFCI protection per the 2020 NEC. A basement is a basement, and a basement is defined as being partially or entirely underground and subject to wet or damp walls and floors. This location requires, like I said, both AFCI and GFCI protection for the receptacle circuits. And by the way, as an aside, AFCI protection is also required for the basement lighting circuits. All right, let's talk about outdoor outlets, not necessarily receptacles. By definition, an outlet is a point on the wiring system at which current is taken to supply utilization equipment like luminaires, appliances, and HVAC equipment. The 2020 NEC section 210.8F, as in Francis, required that all single phase, that is 120, 240 volt residential circuits that feed outdoor equipment must be GFCI protected. Well, this rule sort of caught the HVAC industry by surprise. So what happened is that the outdoor split units for some heat pump systems would trip the GFCI and mess up the HVAC operation. This problem went viral on the internet, on the electrical sites, and the TIA, Tentative Interim Amendment, was issued by NFPA backing off on the GFCI requirement at least until January 2023. Stay tuned on that. Note, this does not eliminate the requirement to provide GFCI protection for the split unit outdoor unit unless it is the type that uses power conversion for speed control and constantly trips the HVAC split unit circuit. Not all heat pumps are like that. So, I mean, the reason this rule came in is because a young boy was electrocuted on an outdoor split unit. Also, not too long ago, and I may have already told you in the other sessions about this service guy who was found dead laying on the ground working on the outdoor unit, and he was electrocuted. So there is a body count, and that's the reason why the code making panel wants to have GFCI protection for these outdoor outlets. Now, once your state adopts the 2020 NEC, don't forget you will have to provide GFI protection for all outdoor electric vehicle chargers also. Whether direct wired or connected using a plug-in receptacle, the EV chargers will need to be GFCI protected. Pay attention. I said when the 2020 NEC is adopted in your area. All right, let's move into the finished wiring for the attic space. If there's a stairway and a man door, for example, or there is a 2-foot by 2-foot access hole, there are rules to follow. Generally, in the attic, electricians will not drill out the roof rafters and would do surface attachment of the cable instead. So if you run the NM cable on the underside of the rafters, it has to be located per section 334.23, which refers you to section 320.23, which requires guard strips on the rafters or studding if this cable is installed less than 7 feet from the floor or floor joist. Read that section 334.23 and 320.23. If there is only an access hole to get up into the attic and no permanently installed stairs, those pull-down stairs are not permanently installed in my book. So if there's only an access hole to get up to the attic and no permanently installed stairs, the Romex cable must be installed at least 6 feet away from the hole edges, or if it is within 6 feet of the hole, guard strips must be installed. The thinking here is that if people are going to store boxes of anything in the attic, these boxes would be shoved up in the area within 6 feet of the hole. A guard strip would be generally a 1x3 or something like that. It has to be at least the thickness of the wire. And it's so that any boxes would be sitting on the guard strip instead of sitting on the cable itself. Smoke alarms are not usually installed in attics. Reasons include the temperature can go lower than 30 degrees Fahrenheit and higher than 100 degrees Fahrenheit, and the manufacturers don't like that. Also, since the air is not conditioned and filtered, there are problems caused by humidity, insects, dust, and contaminants. So it's not a friendly environment for a smoke alarm. If someone insists on an alarm in the attic, it would generally be the heat detector type. Check with the manufacturer and follow their recommendations, because there's a rate of rise heat detector that detects how fast the heat rises, and that would be a signal that there's flames and that the heat is rising fast. Or it could be a set temperature, like if the heat detector reaches, I don't know, 250 degrees or something like that, it would go off. So, but anyway, check with the manufacturer and follow their recommendations if you are going to put something up in the attic. Also in the attic, let's talk about roof fans. One item that may have been addressed during the rough-in stage is the installation of an attic fan. And not to worry if you forgot to wire it, because the easiest installation is putting in a solar powered fan. This is a real money saver because the solar power fan does not use electricity from the electric service. You don't have to spend money for material to wire this thing up. Doesn't need it to be on a circuit breaker. The solar panel makes electricity for the fan whenever the sun is shining. So when the sun is shining, the attic's hot, that's when the fan runs. These solar roof fans are also excellent for replacing the hardwired type of roof fans, of which I guarantee you only half in the United States are even running, because they're burned out and nobody knows about it. You got to go to replace an old electric roof fan. It's a beautiful thing. All you have to do is go up on the roof. You don't have to go inside the house at all. You can safe off the wiring and put the solar powered fan in and seal it up. Exterior luminaires. Let's talk about installing the exterior luminaires, what used to be known as light fixtures. For wall-mounted lights, use one of the many trim blocks available to provide a professional look. Whatever you do, the NM cable must terminate in a junction box or a light box of some sort. It can't just poke through the wall or through the siding and then get wire nutted to the light conductors. For any soffit or porch luminaires, be sure to use the correct type. Make sure it says on it approved for wet locations or approved for damp locations, and that has to be stamped on the product. And there'll also be a label on the luminaire itself. Too many times a dry location light is installed outdoors on a porch under the roof, and the people wonder why the light gets filled up with bugs. And it's not built for that location. So make sure you use the right type of luminaire. All right, so there you have some insight and some tips for the final wiring, but we're not finished yet. We have smoke alarms and carbon monoxide alarms and other things to talk about. And I should be able to wrap them up in session number 25. But for now, Van Wert out.